For the second part of the notes, this is proportional parts in parallel lines, which is a corollary to the side splitter theorem. It says if 3 or more parallel lines intersect 2 transversals, then they cut off the transversal's proportionality. So they're saying like this AC, you could put that over CE, and the BD over the DF. So kind of similar to the triangle, where you have that pattern of the top to the bottom, top to the bottom, top to the bottom, top to the bottom. Okay, so we would say if line M is parallel to line N, which is parallel to line P, then we would say AC over CE, and then BD over DF. So let's put this into practice with the math. So I would go 45 over 18 equals 52 over x. And then I would solve. So 45x multiply, we get 936. And if we divide, we get 20.8. Okay. So in B, I'm going to go 12 over 30. And then 14 over x. So 12x and 420, and if you divide, we get 35. Okay. For letter C, I would do x over 27 but then I would do 32 minus 18 to get this missing piece, and that would be 14. And then, since I started with x here, over 27, I got to go 14 over 18. Cross multiply and divide by 18, and we get 21. D, very similar. Okay, so I would want to take 92 minus 28 to get this missing piece, which is 64. And then I would do 28 over 64. And then 31.5 over x. And if I divide by 28, we get 72. Sorry for the interruption. We'll continue with letter E. So in letter E, this also is very similar to the very first example. Kind of some basic equations, cross products, and then we throw in a little bit more algebra with the expressions. Okay, so 24 over 18 3x plus 1 over 12. And 24 and 18 are obviously divisible by 6. So I would divide those by 6 and get 4 thirds. And then it would help me solve. So 4 times 12, 3 times the quantity 3x plus 1, and then distribute, subtract my 3, and if I divide, we get 5. Okay, letter F, we have 2x plus 2 over 21. And then we have x plus 3 over 12. So go ahead and cross multiply. Distribute. If I subtract 21, we get 3x. If I subtract 24 from 63, I get 39. So x is 13.